Hi everyone and welcome back. Today we're going to take a look at completing the square, one of the most fascinating methods of solving equations. Right, so I'm just going to get right into it. Now when it comes down to completing the square, let's say we are given an equation like x squared plus 6x plus 2 is equal to 0. The first step would be to essentially, keep the terms that are containing x on the left-hand side. So you want to keep the terms that contain x on the left-hand side. So that would mean that you would have to move 2 to the other side, or just subtract 2 from both sides in an effort to get it to the other side. So you would have x squared plus 6x is equal to negative 2. The second step, which is step 2, you have to think about a number that makes the left-hand side a perfect square, which would be kind of impossible because, it's kind of difficult to think about a number that would be added to the left-hand side to make it a perfect square. So you can kind of figure in a way you can say a type of a formula that always works when it comes down to completing the square. And that is, if I add essentially the coefficient of b, the coefficient of x, which is b, divided by 2 raised to the power 2 to both sides, I will always get that number, which would give me a perfect square. If you don't believe me, let's go ahead and take a look at that. For example, if I add, essentially what I'm saying is I'm adding b over 2 raised to the power 2 to both sides, by the way. Why to both sides? Because if I do anything to the left-hand side, I should do the same thing to the right-hand side in order to kind of balance the equation. So I would have x squared plus 6x plus 6 divided by 2 raised to the power of 2. So b over 2 to the power 2 would be 6 divided by 2 raised to the power of 2, which would be essentially 3 to the power 2, which is 9. Plus 9 is equal to negative 2 plus 9, which is 7. Okay, so now as you can see, I have an equation. And you may be asking yourself, well, why did I do this? Why did I go, this whole way to get x squared plus 6x plus 9 equal to 7? Because that is obviously clear that I can now make a perfect square, right? I can factorize x squared plus 6x plus 9 and make it a perfect square. What I mean is that right now I can just think about a number that multiplies to 9 but adds up to 6. So that would obviously be 3. So x plus 3 is equal to 7. Now, as you can see, I got a perfect square because these two numbers make a perfect square of x plus 3 raised to the power of 2 is equal to 7. All right, so now the next step is to just get rid of the power of x plus 3 to the power of 2. That would be to take a square root. And if you do anything to the left-hand side, you should do the same to the other side. So x is equal to negative 3 plus minus radical 7. So why negative 3? Because if you bring positive 3 to the other side, it becomes negative. And why positive minus radical 7? Because when you take a square root, you get two solutions. One positive, one negative. All right, so this is the way we do it when it comes down to, essentially you can say that this is certainly a bit easier compared to other types of completing the square. Another type of completing the square that we're likely to get is when the coefficient of a is not necessarily 1. What I mean by that is if you get something like 3x squared plus 4x minus 15 is equal to 0. Now look at the difference. Over here, a is not equal to 1. But if you look at the question that we did before, x squared plus 6x plus 2, you can see that obviously the coefficient of a, or x squared, is actually 1. All right. In order to do this, it's all the same thing, except you have to get rid of that coefficient. You have to turn it into 1. So you just write first 3x squared plus 4x is equal to 15. Step 1, essentially keep the terms that contain x on the left-hand side. All right, that's step 1. The second step is to divide the whole equation by whatever the coefficient of x squared is, which is 3 in this case. So we divide by 3, divided by 3, 15 divided by 3. this simplifies to 15 divided by 3 would simplify to 5, and 3 over 3 is obviously 1. The third step would be essentially so you have x squared plus 4x over 3 is equal to 5. Now, same thing, you just have to add the coefficient of x, which is b over 2, divided by 2, raised to the power of 2 to both sides. So you're just going to have to add essentially 4 over 3 divided by 2 raised to the power of 2. Now, here is where most technical difficulties kind of arise, because most people don't know how to divide 4 over 3 by 2. Well, just give 2 a denominator of 1, far, far, near, near. So keep 4 on top. 4 times 1 is obviously 4. 3 times 2 is 6. This can be simplified with 2, which would give you 2 over 3. Then you'd have to raise it to the power of 2, because it's obviously raised to the power of 2 added to both sides, which would give you 4 over 9. Okay, so step 4, we now have, let me make that a bit neater. Step 4, we would have x squared plus 4 over 3x plus 4 over 9 is equal to 5 plus 4 over 9. We're adding 4 over 9 to both sides. Okay, so now we have essentially an equation which can be factorized. What number multiplied would give us 4 over 9, but adds up to 4 over 3, right? I'm just factorizing this left-hand side. So you can either do that, or you can just take a look at a step before this, which was step 3, and the number that you squared before would make the left-hand side a perfect square. In fact, 2 over 3 times 2 over 3 would give you 4 over 9, and 2 over 3 plus 2 over 3 would give you 4 over 3. So the perfect square is x plus 2 over 3 raised to the power of 2 is equal to 4 over 9. 4 over 9, obviously 4 over 9 plus 5, my bad. Now, 4 over 9 plus 5, on this side, you would have to kind of figure that out, which would be 49 over 9. You can either put it in the calculator or just take a common denominator. Let me do that right here. 5 plus 4 over 9. Just give 5 a denominator of 1. Multiply the denominators, 9. And then just cross multiply. So you would have to multiply 9 with 5 and 1 with 4. So you would have 45 added to 4 times 1, which is 4, which is 49 over 9. So anyways, x plus 2 over 3, back to step 5, to the power of 2 is equal to 49 over 9. All right. Again, in order to get rid of the square, we just take a square root of this side, of the left-hand side, but we should do the same thing to the right-hand side. So x plus 2 over 3 is equal to 49 over square root of 49 over 9, which is 7 over 9, 7 over 3, and positive negative. So the final solution is, take 2 over 3 to the other side, negative 2 over 3 plus minus 7 over 3. Okay, now, as you can see, we can obviously further simplify this without using the calculator, so we'll have two equal solutions of negative 2 over 3 plus 7 over 3, and negative 2 over 3 minus 7 over 3. So this one simplifies into 5 over 3, and the other one into negative 9 over 3, which is negative 3. All right, so there you go. When it comes down to the harder questions, obviously, as you can see, you need to be familiar with a lot of things. First of all, simplifying fractions. Second of all, knowing how to take the common denominator, obviously, when you don't have the calculator. Or basically knowing that when you take the square root of a number, you get two solutions, one positive, one negative. And then, some other simple algebraic things that you should have learned in pre-algebra and algebra 1. For example, over here, when you take 2 over 3 to the other side, it becomes negative. What is actually happening is we're actually subtracting 2 over 3 from both sides over here. But you guys get the idea. Anyways, that's it for today, and good luck.